Your finance team just flagged a $10,000 cost spike over a single weekend. A warehouse was left running because auto-suspend was set to never suspend. Let's explore. You'll learn how to optimize Snowflake costs by managing credits, virtual warehouses, and storage. We'll cover right-sizing, auto-suspend, resource monitors, and more, all with real SQL examples. Snowflake Cost Optimization means managing virtual warehouse compute, reducing storage costs, and minimizing credit waste across both compute and storage. Think of it like a cloud kitchen. You pay for ingredients, storage, and the chef's time compute. To reduce storage costs, you might freeze unused ingredients or buy in bulk. Snowflake charges separately for compute and storage. Compute is consumed by virtual warehouses, billed per second with a 60-second minimum. Storage costs are based on compressed data, and cloud services are minimal. Understanding these components is the first step to optimization. Choosing the right warehouse size is critical. A common mistake is using a large warehouse for small queries, wasting credits. After you write a query, check its load history to guide sizing decisions. This query uses DATEADD to average running and queued queries per warehouse over the last 7 days. If a warehouse is less than 50% utilized, consider downsizing. When a query arrives, Auto-Resume starts the warehouse. After the query runs, an idle period of 5 to 10 minutes triggers Auto-Suspend, stopping it and saving credits. Set Auto-Suspend low to avoid paying for idle time. This command sets the warehouse to suspend after 300 seconds, 5 minutes of inactivity, and resume automatically when a query is submitted. Setting Auto-Suspend to null disables Auto-Suspend entirely, keeping the warehouse running continuously and wasting credits. The fix sets it to 300 seconds, re-enabling Auto-Suspend after idle time. Resource monitors allow you to set credit limits on warehouses or the entire account. You can define actions when a limit's reached, like sending a notification or suspending the warehouse. This creates a monthly resource monitor with a 500 credit quota. It notifies at 80% and suspends the warehouse at 100%, preventing runaway costs. Without a resource monitor, there's no upper limit on credit consumption. A runaway warehouse can cause unexpected high costs. To fix that, first create a resource monitor, then assign it to the warehouse to cap usage and prevent surprise bills. Storage costs are based on compressed data. You can reduce storage by dropping unused tables, reducing time travel retention, and using clustering keys to improve compression. This query shows the largest tables by active storage and time travel bytes. Use it to identify candidates for cleanup or retention reduction. Every query starts here. Inefficient queries waste credits. Use clustering keys to minimize data scanned, materialized views for pre-aggregated results, and avoid select to reduce I/O. This adds a clustering key on the sale date column, which organizes data so queries scan only relevant partitions, reducing compute credits. A single Excel warehouse for all workloads, as shown in the before code, forces small queries to pay for unused capacity. The after code fixes that by using separate warehouses for ETL, BI, and ad hoc queries, letting each scale independently and eliminating those wasted credits. Snowflake provides account usage views for monitoring, including warehouse metering, query history, and table storage metrics. Use them to generate cost reports and set up alerts for unusual spikes. This query uses DATEADD to show daily credit consumption per warehouse for the last 7 days. Use it to identify trends and anomalies. Here's how it played out. A developer created a warehouse for a data load job but forgot to set auto-suspend. The warehouse kept running after the job finished, consuming credits all weekend. The fix was to set auto-suspend to 5 minutes and enable auto-resume, with a resource monitor to cap credits and send alerts. Once a job completes, the warehouse idles for 5 minutes, then auto-suspend triggers. The key change was auto-suspend equals 300, and together these steps ensure cost control. The incident came from setting auto-suspend to null, which disables auto-suspend and lets the warehouse run endlessly. Burning 10K, fix it by setting auto-suspend to 60 so it stops after a minute idle. To diagnose cost issues, start by checking which warehouses consumed the most credits. Then verify auto-suspend settings with show warehouses. Also check query history for long-running queries. Let's review common interview questions on this topic. Be prepared to explain the pricing model, troubleshooting steps, and cost reduction strategies. Minimum auto-suspend time is 60 seconds. 5 minutes is recommended. To recap, always set auto-suspend and auto-resume on every warehouse. Right size based on workload. Use resource monitors to cap spending. Optimize storage and queries to reduce credits. Thanks for watching. The full article and code examples are covered in detail at thecodeforge.io.